Write the area of a rectangle in terms, write the area, let me say, I'll rewrite it. Write the area of a rectangle as a function of its length. Write the area of a rectangle as a function of its length. Write the area of a rectangle as a function of its length. Write the area of a rectangle as a function of its width or length. Once you get it, then let me look at your paper. Once you get it, let me look at your paper. Write the area of a rectangle as a function of its length. Got it? Got it? Still got it? Got it? Yeah, well, it's gonna take y'all longer than 2.5 hours to do the exam. You take that back. It's gonna take y'all 30 seconds, it's gonna take y'all hours to do a problem.
Should we know the perimeter?
What?
Shouldn't we know like the perimeter if you're trying to figure out this?
What'd you say?
Should we know the perimeter? Should we know the perimeter of this problem? That's what she said. Like the given perimeter?
Possible.
Area is
How are we gonna find that
times
answer if we
width.
don't know the given perimeter?
Alright, make up something.
200.
132. 132 feet.
Not gonna give us half the answer.
132 feet.
Trying to shut off her computer.
Is that making that noise?
Yeah.
Yeah,
Pull some plugs out. Thank you.
thank you.
Yeah. the perimeter is 132 feet. You should have it by now, right? Everybody got it? Anybody have it yet?
I know it was like,
132 feet equals what?
this is stuff about the box. He had us write the barn.
And the area is just equal to length times width, right? So we have to go through this. We have to say 132 minus 2L equals 2W, and W equals to 132 minus 2L divided by 2, and this is 66 minus L equals W. So the area as a function of L would be equal to just like that. So this would be A sub L equals minus L squared plus 66L. Does everybody see that? That's the area is written in terms of L.
I got that right.
Does that make sense?
Mr. Smith, I got that one right. I just wanna let you know that.
You got it right?
Swear to God, I had it right.
That's good.
Whatever. I just wanna kudos.
Is everybody okay with this one? Good enough?
I didn't use the over.
Okay, where this will not be confusing to anyone, you may see a problem like this, okay? And you may have on this, better here. See. Everybody see that? What if you had two graphs on this picture, okay? The way you would tell them apart would be a different colored line, okay? So if you had a red line, that would represent a particular function, and they would tell you which one. If you had a blue line, and you very well may have, say the blue line would be like this, and the red line be like that or something, you would know over to the side which one is which. It will be a guess or by gosh. They will tell you which function is the blue one, okay? Because they may have it written just like, and I don't have a, let's suppose this is, that's not even right. They may have it just written out like this, f of x, and they'll tell you that the f of x, it'll be in red, okay? This would be like in red. They may not get, and then of course they may have a g sub x, and it will be what? It'll be blue. So you would then know which function you're looking at on the graph. In other words, if this line was red, then I would be looking at this part right here. And if this line was blue, then I would be looking at what? The blue one. Does that make sense? Because you're gonna have to look at the picture and tell something about it. You'll have to look at the picture and, for example, if this was the blue line, if that's the blue line, and it said that g sub 0 is minus 4, you would know that that's what? That's the point they're talking about right there. Because you go to the blue line, and this would be in blue, this would be colored blue, and you know that's what? That's minus 4. They may ask you, say, okay, we'll put that with g sub minus 3. So what would, I'm sorry, f of minus 3 would be equal to what? 0, because that would be what? This would be the red function. Is that making sense? If you had to put them together, that would be minus 4 plus 0 would be minus 4. That makes sense? It's just, you're just looking at the picture telling what the values are. I mean, it's sort of silly to even think about that. That's one of the problems that they gave you, you know. So I didn't pick out the problems. I didn't make up the problems. In other words, they're already made up. So they're just letting you know that there's two different functions, an f of x, the function f of x, and there's a g sub x. And you have to look at the different colors and to tell which one is f of x and which one is g sub x. It will tell you, in other words, by the colored line. Like I say, if this line is blue and this is blue, then it would be g sub x you'd be looking at. That makes sense. That's sort of a giveaway problem, really. You know, it's pretty much a giveaway.
Maybe easier to make some colors.
What if you're given no matter what they tell you to do, if they say, find f minus g sub x, f minus g sub x, really doesn't matter if they ask you to find this or this. You could be asked to do what? What is the domain? And you don't even have to do anything for this thing. But you would know that the domain would be whatever is the domain over there. No matter what you get, once you add them together, you still are restricted with what?
All real numbers.
No matter what you get, if you add or subtract them or multiply them or divide them, the domain is still gonna depend on what? The domain of those two things. What's the domain of the first one?
All real numbers.
What's the domain of the second one?
X can equal 2.
X cannot equal 2. So no matter what you do to it,
So,
they may just ask you, what is the domain? Well, it's a very simple answer is what?
all real numbers except
All
two.
real numbers except 2. So you don't have to do anything to the problem to determine the domain. That establishes the domain over there. You may take these two functions and put them together in such a manner that it looks like you could use any number in the world. But it still depends upon what you started out with, you're not allowed to use. Does that make sense? It's like, it would be like saying this. No matter what you're asked to do with those two functions, and they ask you for the domain, what would you tell them? What would you tell them? No matter what they ask you to do, whether they ask you to add them or subtract them or even find the composite of one versus the composite of the other one, you would still say, what is the domain of your result?
All real numbers.
It have to be what?
All real numbers.
Why?
Because it can be all real numbers.
Why is that, everybody? Because there's nothing that will make either one of these 0. I mean, the only one you gotta worry about is this one. This is the one that contains what? A denominator. And you guys gotta make sure the denominator is not 0. That you can't make 0. Not with any real numbers in the world. You can try them all, and you'll never get a 0. So, no matter what they tell you to do with those two functions, whether it's to add them, subtract them, multiply them, find the composites, or whatever else, the domain would be all what? Real numbers. That make sense, everybody? that they ask you is not asking you to work out any problem to get a number. It says, you know, find the expression. That means find the equation, right? Or find the expression for the, whatever they're asking you to do. You may not have enough information to get what a number is a concrete answer, but it might be just asking you for an expression. But you look at the answers and say, well, none of the answers are what? It's like a number, so they must be asking me to find the equation of the problem. How do you know when you have an inverse function? How can you determine if something, what an inverse function would look like? Y'all remember from yesterday, day before yesterday?
Fold the piece of paper in half.
You fold it? Wow. You're right, but fold it in half?
Like diagonally?
What?
Diagonally?
Okay, yeah. Then hold it up to the light, right?
Mm-hmm.
And then whatever that makes would be what? Would be an inverse function. If you were given this picture like this, and you folded that across there like that, and held it up to the light, what would you actually think you're looking at? You would think it would be something like that, right? That's what it would look like when you held it up. If you still made that what? The X and Y axes, it would look like what? It would be something like, it looked like this. Everybody see that? Everybody? If you were to do it, try to take two pieces of paper, put two X's and Y's at the same place. Draw it on one, fold it, and hold it up to the other one, and you can see. In other words, let the one that you got on the bottom be the one you fold, and you hold it up, still square. You can obviously see which one it would be. Okay? That was sort of silly though. What about this? That converts what?
Five ninths minus 32,
What now?
maybe. 5 ninths C minus 32.
What does that do?
What does that do? It
Yeah.
converts Celsius to Fahrenheit?
It changes Celsius to Fahrenheit. It converts Celsius to Fahrenheit. Okay? calculate the Celsius temperature if you've been given the Fahrenheit. In other words, what is the equation for the Celsius temperature? What is the equation for the Celsius temperature? Find the equation for the Celsius temperature.
Celsius equals 9, 6, plus 42.
Everybody got it?
I don't remember.
No? Yes?
I don't.
You got it?
No.
No?
Don't remember. I never learned those.
Huh?
I never learned those. Sorry.
But this is just algebra.
Yeah.
That's
Oh,
just an
you
algebra
want me to
problem.
work it out? Okay.
Hurry up. Miss Bradley, what you got?
9/5 plus 32?
What?
Oh, yeah, 9/5 minus 32.
C equals 5/9 F minus 160 over 9.
What the hell?
Who said that?
What's 5 times 32? Divided by 9. 5/9 F minus 32. 5/9 F minus 32.
Ouch. Be careful.
What?
You got that? You didn't leave that out, did you?
I thought it was 9/5 plus 32. Paper.
No, didn't leave this out, did you?
Parentheses?
Parentheses? You got it in parentheses?
No.
No? Look, everybody look up here a second. All you have to do is solve this equation for C, okay? Solve this equation for C. It's quite easy because you just do this. F minus 32 equals what? Everybody okay so far? And so now you do what? Multiply by the reciprocal. And there it is.
I said that like 4 times. He never acknowledges
You didn't put it, you left out the parentheses.
Well, I was right, that's how I said
Is that what you got? Did you get it like this?
Mm-hmm.
You didn't leave out the parentheses.
I'll put them on there, no.
Let's see.
No, you don't.
Let me see.
No.
Let's see.
I'm a verbal speaker, I didn't write it down.
No. What is it, on your computer? No.
I did say that when you kept asking me what I said, but I didn't put parentheses. Cause you asked
But
me
heck-
what thing was for C.
You gotta have the parentheses. If, do you, look at this, everybody. This is actually this. So when you're looking at those two equations, what can you tell me about both of them?
They're inverses.
They both got temperature?
C is a function of the.
But what can you tell me about both of those equations? Somebody talk to me.
the same number.
They're what?
Come over the same number.
They're conversions. They're functions. See, there's too many answers to this question, so.
What can you tell me about those two equations?
They're a function of each other.
What?
They're a function of each other.
Nope.
Yeah, they are.
That's not the answer he's looking for.
What about those two equations?
They're temperature related.
Damn it, they are linear.
Linear? Oh my god.
They are both linear equations.
Never acknowledged.
Both of them are linear. And guess what?
They're inverse.
They don't have the same slope. What does that tell you about those two equations? If they are linear and they don't have the same slope, then they must do what?
Cross.
Cross at some point.
Okay, one thing.
You've got, don't you see that, everybody? That's important to be able to look at that and say, look, both of them are linear, and they don't have, one of them has a slope of 9/5, and the other one has a slope of 5/9. That's not the same number. So when they have different slopes, that means they have to do what? Cross at some point. So that would tell you, just in a snap, that somewhere, both of them will be the same temperature. If you hang both of them side by side, one of them's a Celsius and one of them's a Fahrenheit thermometer, at some point, David, listen, at some point, they're both going to read the same value. And where will that be?
Is it point of intersection?
Where will that be?
Point of intersection?
Where will that be?
You actually went over this.
Without looking back. There you go, looking back.
It was like negative.
Without looking back.
Negative 32 or something like that. 42.
Say it loud, Eric. Say it with confidence. I'll tell you what he said. He said absolute zero, which was absolutely wrong.
It was like,
Point of intersection.
You cannot obtain absolute zero.
it was at,
Silly though,
it was
eh?
at
What
a-
is absolute zero?
Zero.
Anybody know what absolute zero is?
Really, Eric
You
called
don't?
That sounds like a
What?
philosophical question.
What is it?
Absolute zero is freezing in Celsius, and 100 is boiling.
No. It is minus 273 Kelvin.
I knew that. It's Kelvin.
Kelvin.
Ouch.
Minus 273 degrees Kelvin. Did anybody say that? I can't.
Oh yeah.
Yeah.
I can't hear.
I knew that.
They cannot, why is it impossible to reach that temperature? Does anybody know why it's impossible to reach that temperature? It is impossible.
Air will freeze.
Simply because, listen up, folks. This is not for this class. This is for when you get out in the real world
Oh,
and
someone stop.
you may be asked these type of questions. Nobody knows what they're going to ask you. But really, they can't obtain that because when all molecular activity would have to come to a halt. And when the molecular activity comes to a halt, nothing can possibly be there. Nothing can be there. So even where they would suspect, and you would expect absolute zero to be, would be in space. And guess what? It's not. It's approximately 0.7 degrees, 0.7 Kelvin, rather than minus 273. It's minus 272.3. Why is it not absolute zero? That was a startling revelation to us. it gives you concrete evidence of the residual energy left over from the Big Bang. That's where it's come from. It's the residual energy that's still out there from that. Otherwise, it would be absolute zero. There would be no molecular activity out there. Something caused the molecular activity to still exist out in space. Am I making sense or not? Because you never, listen, I'm telling you folks, I've worked in industry, I know. I worked for quite a few years in industry, and I don't know about you all, but I've been tested time and time and time again for promotions. Whether it was in the Army or whether it was in civilian life. Some of the silliest things. As a matter of fact, I'll give you an opportunity. Ready? Get your piece of paper and pencil out. This time I'm going to give you a minute. They gave us 10. Okay? We'll give you a minute, and when I say go, I want you to do this. They put me in a room, in a closet, just a small room, with just a desk and a chair and nothing else. Absolutely nothing on the walls, bare walls, almost soundproof. And they stepped in the door, handed me a sheet of paper, and they went back out the door. He said, without the naming the following, I want you to do this. I want you to write down as many occupations as you can. Go. It's not funny. This is serious. It damn depends on whether you get promoted or not.
Hey, what did he say to do? I didn't really understand the question.
What?
Or what did he say to do? I didn't really understand the
Oh,
question.
write down as many occupations as you can.
Okay. Or what do you mean by occupation?
That's what it, yeah, just that's what it says.
Jobs.
Go. You gotta hurry because you only got a few more minutes. I mean, another few seconds. Okay, stop. Put your pencil down. Count how many you have. Count how many you have. I'll start up here. How many did you get?
11.
11.
Okay.
21? 10? 5?
9.
10?
7.
14.
12.
11. You got how many?
10.
Who got 21? She what? She wins.
Well, there were people talking, so it was hard. We weren't in the room. Start over. Do it again. She was talking.
Name them. Name them. Y'all listen.
Teacher, principal, sociologist, student, cook, scientist, historian, bookkeeper, speaker, preacher, priest, governor, judge, lawyer, doctor, police, fireman, senator, spokesperson, model, and librarian.
I only put hot paying jobs.
I got more than anybody. As a matter of fact, I got more than double the next person. That's what I hear. You doubled everybody. I didn't do mine like that.
I mean, you did have 9 more minutes than we did, so.
How? Name yours.
Teacher, doctor,
That's
hair.
done. Name yours.
A lawyer,
Name yours.
Teacher, doctor,
Name
preacher,
yours.
stripper.
Veterinarian.
Name yours.
Astronaut, receptionist, marine biologist,
Yeah,
flight
come on.
attendant.
What you got?
Doctor.
Nobody did what I did.
What?
I put everything.
Drug dealer, prostitute.
What?
She
What?
made more money than anybody.
What would you do?
I did it alphabetically. I started with the letter A and named everybody I could with the letter A.
Smart.
I went to B, I went to C, I went to D, I went to
We
E.
had 1 minute and somebody was talking 97% of the time.
You had 9 more minutes, so that's still cheating, so yeah.
But
Yeah.
Can't everything be considered
But-
an occupation?
What now?
Can't anything be considered an occupation? Like anything you can do?
I don't
can be
think so.
considered an occupation?
Yeah.
Like you can be a poet, and can be considered an
Yeah,
occupation.
be an occupation, yeah, it's
Scratch your
occupation.
ear, are you an ear scratcher?
Yeah.
I didn't restrict it to
No,
anything.
you're an ear scratcher, you know?
I bet you
I
can find
never
somebody to pay you
said,
money.
I
Scratch your ear.
was loving your ear, I just said I scratched
Look,
it.
you scratch my ear, I'll give you a dollar.
I'm not touching
That's an
your
occupation.
That's what I had to do. That was the question, that was the test. The-
For what job?
For a promotion,
What job? What job was it?
I'm gonna sign him up already smarter than a 5th grader.
they were promoting to, like shift supervisors.
I'm smarter than Einstein.
But I've been tested dozens and dozens and dozens of times. Have y'all ever done that? Never?
Yeah, in my algebra class.
I got a question for you. Alright, you have 10 apples. You give 3 apples to Eric. How many apples do you have? 10, because you still have apples.
That made no sense.
Okay. I have no idea. Somebody said I was messed up.
You just said another way the joke went, did you?
I forgot how the joke went.
What the hell?
I think I messed it up.
Yeah, you did, cause nobody laughed at you. We were laughing at you.
It's okay.
In the orbits where you're given test after test after test after test, they don't know when to quit giving you tests. If you pass one, they give you another one. They just keep on and keep on and keep on and keep on and keep on. If you do a lot of reading, if you've not read this book, I highly recommend this book. It's in the library, and you can check it out. And it's called The New Thing. And it's about Jim Clark. And the book is not about, it's a lot about him, but it's also centers around what he accomplished. He's probably the only person that I've ever read about that's starting 3 different companies that made himself and others billionaires 3 different times over. If you've ever heard of a company called Netscape, and you probably heard of him. If you ever heard of a company called WebMD, then you've heard of him. He wrote his business plan out on a napkin, and he realized that a young Georgia Tech student, he was 27 years old, Georgia Tech recent graduate, had already started something like what he intended to do. He hopped on his private jet, flew to Atlanta, Georgia, tracked the young man down, and gave him $35 million cash for his company. Yes.
Okay, so the problem on the board that you just answered, why did you answer that in Kelvin?
What
Those
now?
are absolute zero.
Although,
Did you want the answer to that?
Yeah,
Oh, it's -40.
-40, yes. How'd you get that?
Well, since you're trying to find where they're equal to each other, C and F are equal to each other, so you can just take out one of the variables and just solve one of the functions.
Yeah. All you have to do, folks, is just do this, is just ask yourself a question, what is F equal to C? Solve that equation for C, real quickly. Solve that equation for C. Y'all hurry. And the reason why is because it looks a lot like this, you all. Or like that. That's where they would cross at -40, -40. Anybody get this solved? You finished? Got it? Anybody not have it?
I had a question about inverse functions. Do you have to fold it over the line y equals x, or can you fold it at any point in the graph?
No, it has to be at a 45, right across the center,
Yeah.
right here.
Okay. So when I was saying they were inverses, I solved for the inverse before I solved for C, and the inverse equaled the same equation as C.
Is what now?
Never mind, I'll tell you later.
Yeah, okay. Everybody get this? Anybody get this? Just do this. It's just this. 5C equals 9C plus 160. This is 5C minus 9C equals 160 minus 4C equals 160. C equals -40. Everybody follow what I did? That it?
Yeah.
Simple enough?
That was kind of a trick question. Kind of threw me off.
It's what?
It was kind of a trick question at first, because it was like, you asked, for us to solve it, and so for a second, I don't know, for a second, I just didn't realize that it was like, wait, he's asking for where they're equal at, so you can just take out one of the variables.
Well, that's what you did.
Yeah, I didn't get that for forever. I sat back here for like 10 minutes trying to figure that out.
Oh, really? Oh, okay, yeah.
So my test might take me a little while.
This is a simple way to do it right here. Just make F equal C. Tell me when F is equal to C. So if you had them side by side and you got to be -40 degrees, they would both read the same temperature. They would have to. At 0, it's what? It is freezing with Celsius. At 100, it is boiling. At 32, it is freezing Fahrenheit. And the boiling point is what?
212.
I heard it, somebody say it.
212.
212. 212.
Yeah, temperature.
That's why the Celsius temperature means the most, because scientifically, because if you did this, I think we went through this one time before, if you built a little box, and that box is 1 inch by 1 inch by 1 inch, the volume is 1 cubic inch. Everybody see that? And Lord knows how much water will go in that box. And heaven help us if we had to calculate the amount of BTUs it would take to raise that 1 degree Fahrenheit. Mind-boggling. But at the same time, I want you to think about making the box 1 centimeter by 1 centimeter by 1 centimeter, and now the volume is 1 cubic centimeter. Is 1 cubic centimeter. And the amount of water that will go in that box is 1 milliliter of water. Some of you all aren't paying attention, and you're going to pay for it one day. Maybe not in this class. But that 1 cubic centimeter of water is 1 milliliter of water, which has a mass of 1 gram. And that 1 gram of water can be raised 1 degree Celsius by applying 1 calorie of heat. To raise 1 gram of water, which is 1 milliliter of water, from 99 degrees Celsius to 100 degrees Celsius, costs you 1 calorie of heat. To raise that 1 gram of water from 100 degrees Celsius to 100 degrees steam, it costs you 540 calories of heat. You need to know that. You absolutely need to know that. There is no temperature change, there's a change of state. And to go from a change of state, it costs you 540 calories of heat. What does that say about what I just told you? What should that tell you? What should that say to you? That's all. That tells you that steam is 540 times hotter than water. That's why when you get burned by steam, it's a horrible, horrible burn, because it's 540 times as hot. You can put your finger in boiling water and bring it back out. I want to see you put your finger over a steam kettle, and before you can get it away from the steam kettle, you'll have a blister on your finger. Wonder why? Now you know why. Because the steam is what? 540 times as hot as the water. So that means that what? That a liter of water has the mass of 1 kilogram. That's the sensible system. That's the sensible system. And the quicker we move to it, the better off we'll be. I don't have the time. It's pretty close to That's been open. I'm about exhausted myself. I was sick all day yesterday, so I still got another class to go, so. But, anybody have any questions that you want me to address that,